Good morning, everybody. We're going to continue our word problems, and today we're going to talk about word problems that include area. Okay, we're going to talk about area problems, area, and setting up these quadratic equations. So let's just talk about area in general. Do you know how you find area? Well, I guess it depends on what figure, but if you look at the first figure and even the second one, we're talking both times about a rectangle. Okay, so just remember that your area of a rectangle is length times width. Okay, so this one says that a rectangle has an area of 24 square units. So the first thing I'm going to do is draw myself a rectangle. Okay, and if I know that my area is 24, I'm going to put it right in the middle. Area equals 24 square units. Then it tells me that the width is 5 units less than the length. So which one do you know nothing about? The one that you know nothing about is your original x. So if you know that the width is 5 units less than the length, you know nothing about the length. So you're going to automatically let x equal length. And if you know the width is 5 units less than, then you're going to let x minus 5 be your width. Okay? So think about it. Here's your length and your width. Well, if we go back to our original, knowing that our area is equal to length times width, we have our length and our width. Our length is x times our width is x minus 5, and we know what that equals. What does that equal? 24 square units. So now we're going to solve this quadratic equation. We're going to distribute that x. X times x is x squared. X times negative 5 is negative 5x. And that equals 24. Do we want our quadratic equation? Remember, ax squared plus bx plus c equals 0. Do we want it equal to 24? No. We're going to subtract that 24 to the other side. And we have x squared minus 5x minus 24 equals 0, which once again is a basic trinomial. So you're asking yourself, okay, what multiplies to negative 24 and adds to negative 5? It's got to be negative 8 and positive 3. So x minus 8, x plus 3 equals 0. And when we solve our two little mini factors, x minus 8 equals 0 and x plus 3 equals 0, if we add our 8 to both sides, x equals 8. And if we subtract our 3 from both sides, x equals negative 3. Now, what does x represent? The length. Can your length be 8? Yeah, that makes sense. Length can be 8. Can your length be negative 3? No. So I'm going to reject this and just write that length cannot be negative. Okay, so I'm going to just highlight our answer of x equals 8, and I'm going to plug it in there. Now, if I now know that the length is 8, how can I find the width? I could just do this, 8 minus 5, and now I know my width is 3. So your length, which I believe is what they asked for, your length in units is 8 units. Okay? And it makes sense, because if I put in an 8 here, and 8 minus 5, which is a 3 here, what's 8 times 3? Length times width. Oh, 24, exactly what we got back. So that makes complete sense. Okay? All right, let's try another one. Let's look at the soccer field. So this says a school is building a rectangular soccer field that has an area of 6,000. So we're talking big numbers here. 6,000 square yards. So I'm going to draw my soccer field. And I already know that my area is 6,000 square yards. Okay. Area 6,000 square yards. Now it says the soccer field must be 40 yards longer than its width. Okay, so that's tough. 40 yards longer means the length has to be 40 yards longer than the width. So which one do you know nothing about? The width. Let's immediately let x equal our width. Okay, we don't know anything about the width. What do we do know? We do know that the length has to be 40 yards longer. X plus 40 is our length. Okay? Determine algebraically the dimensions of the soccer field. Well, once again, if we're talking about a rectangle, your area is length times width, right? And again, the order doesn't matter. If I know that my width times my length equals my area of 6,000. Okay, so once again, look, I'm just going to distribute because now we're going to try to solve for x, the width. I get x squared plus 40x. Don't forget that 40x equals 6,000. And we don't want that 6,000 there. I'm going to subtract that from the other side. And you have this crazy number. You have x squared plus 40x minus 6,000 equals 0. Okay, so now you're saying to yourself, this is a trinomial. And you're going to say, okay, what multiplies to negative 6,000 and adds to 40? Kind of crazy numbers. Now, what you could do is you could go into your calculator, right? I'm going to clear out everything I have. And you could do your negative 6,000 divided by x, okay, and look at your table of values. Now, here's the problem with your table. I'm just going to go from, I don't know, negative 2 to, now, we gotta talk really big numbers here. So, I'm going to make my step 2 because that's going to go every 2 numbers, but I'm going to go all the way to, let's just say, 100. Let's see if it'll do that for me, right? So we're looking for 2 numbers, right, that are going to multiply to 6,000, like negative 2 and 3,000, 2 and 3,000, 4. But their difference has to be 40. See the middle number? 40. So when I come back here and I start looking, well, okay, as I keep going, I'm getting closer. Like 30 and 2,000, 30 and negative 200 has a difference of negative 70. So I got to keep going. 40 and 150, that has a difference of negative 110. 50 and negative 120. Oh, look at this. 60 and negative 100. Okay, so I'm going to write those 2 numbers down. 60 and negative 100. What do those have a difference of? If I added those together, they definitely multiply to negative 6,000. They add to negative 40. So if I flip the signs, negative 60 and positive 100, that's what I want. Those 2 multiply to negative 6,000, and they add to positive 40. So I'm going to do x minus 60 and x plus 100. Big numbers, but not such difficult numbers. Okay, so when I set up my t and I take each factor and set them equal to 0, I do this little mini equation. If it's x minus, now I'm going to add 60. Why? It crosses it out there. And now I have x equals 60. And here, if it's x plus 100, I subtract 100, do the inverse, and I get x equals negative 100. Now, could both of those be, so remember, I forgot to put an x plus 40 on the length. Could both of those be the width? Could the width be 60? Yeah, this width could be 60. That makes sense. If I use a new color, If my width is 60, what would be my length? 60 plus 40, which would be 100, which makes sense. If this was 100 and this was 60, 100 times 60 is 6,000. Now, could your width be 1,000? No. We're going to reject because your width can't be negative. Okay? So when you're talking these word problems, remember that your length and your width, your age, any type of dimension or real life application usually can't be negative. Okay, let's try one more. So this is a great question. This was a Regents question. Jack is building a rectangular dog pen. Okay, so immediately I'm thinking to myself, okay, let me draw this rectangular dog pen. Okay, so what do we know about this rectangular dog? The width of the pen is 2 yards less than the length. Okay, so which one do we know nothing about? The length. I'm going to immediately let x equal length. I know x's length because I know about the width. The width is 2 yards less. So x minus 2 equals width. And remember, if we're talking area, which is the piece in the middle, area is equal to length times the width. So the area, they tell you, is 15 square yards. Now, the question actually is asking, and I'm going to go new color for this, how many yards of fencing would he need to completely enclose the pen? So we're going to talk about that for a second, but right now, if I need to figure out how many yards of fencing would enclose the pen, what are they really talking about? Are they asking you for the area? No, that wouldn't make sense. And to be honest with you, the area is given. If they want to know fencing, think about where you put your fencing. Here's your fencing. What is this question really asking you for? Your fencing is asking for the perimeter. They want the perimeter of this question, of this dog pen. So in order to get the perimeter, we're going to have to solve for x and add up all the sides. To get perimeter, we add up all sides. Okay, so if I know the area is 15, I know that my length times my width is equal to 15. So I know to solve for x, I'm going to distribute x squared minus 2x equals 15. Move that 15 over. So x squared minus 2x minus 15 is 0. And once again, you're looking at a trinomial, and you're asking yourself, what multiplies to negative 15 and adds to negative 2? It's got to be a negative 5 and a positive 3. So that means you can go right here. You don't have to split the middle. A is 1. You just bring over x minus 5 and x plus 3. The order of those factors doesn't matter as long as the positive's with the 3 and the negative is with the 5. So when you set up your t, set them equal to 0, you do your opposite, add 5 minus 3. So x equals 5 and x equals negative 3. Could both be answers. Can I have a length of 5? Yeah. Can I have a length of, I wrote 3 instead of negative 3. Can I have a length of negative 3? No. So immediately reject that negative. Can't be. But this 5 is looking good. Now remember, with that 5, that's your length. Your width is 5 minus 2. So your width is 3. That means this side is 5. This side is 3. Now remember, in a rectangle, opposite sides are congruent. So that side is 5 and that side is 3. So in this question, it's like, oh, they didn't just want the length or the width. They want the perimeter. How do we find the perimeter? We add up all our sides. 5 plus 5 plus 3 plus 3, which is 16, which means they need 16 yards, right? We were talking about yards here. Yards to enclose the pen. So what happened on the Regents, this was a 4-point question. Most kids did great and they solved and they got the length and the width, but then they didn't answer this question of how many yards do they need to enclose the pen, okay, which was perimeter. All right, so that's it. Those are the 3 questions, just all about area and length and width with a rectangular figures. So I'm going to give you guys a couple of practice questions and you're all good to go. Okay, have a good day. Let me know if you need me.